Welcome back to the channel. Today we are going deep, literally. If you're in structural engineering, concrete scanning, or heavy-duty construction, you know that the guess and check method for locating rebar is a recipe for disaster. One hit on a structural tension cable or a primary rebar grid can cost thousands in repairs and compromise the integrity of the entire build. That is why we are looking at the heavy hitter, the Hilty PS300 Ferris. This isn't just a stud finder for concrete. It is a high-precision scanning system designed to give you a transparent view into reinforced concrete elements. In this comprehensive guide, I'm going to take you through everything. We're going to cover professional project organization, the physical hardware setup including the telescopic pole, the quick scan and record workflow, and how to interpret the data right on the screen. By the end of this video, you won't just know how to turn this on, you'll know how to manage a professional scanning project from start to finish. Let's jump in. Before we scan a single inch of concrete, we have to talk about something most people skip: data management. On a large-scale project like a high-rise or a bridge deck, you might be taking hundreds of scans. If those scans are named File 1, File 2, and File 3, you are going to be in a world of pain when you get back to the office to write your report. Let's look at the instrument. We're going into the Projects menu. Think of a project as your main folder. I'm naming this one C1 column because that is our primary focus today. But look at the metadata options here. Hilty allows you to enter the specific location, the object type, the customer name, and even the specific user. Why does this matter? Because when we eventually export this to the Profire software, all of this data tags along. It allows you to filter your results instantly. If your client asks for the cover depth statistics for the third floor columns only, you can pull that up in seconds if you organized it here first. I'm also going to create a second job called Slab 1. This allows us to keep different structural elements separate within the same project. Remember, the more work you do now on the interface, the less work you do later at your desk. It's about being a professional, not just a technician. Now let's talk about the physical challenges of the job site. You aren't always scanning at chest height. Sometimes you're looking at bridge soffits, high ceilings, or the top of a 15-foot column. This is the Hilty telescopic pole. A lot of guys try to balance on ladders while holding the scanner, but that's a safety risk and it leads to shaky, inaccurate scans. This pole is specifically designed for the PS300. Notice the mounting bracket. You have these two alignment holes on the side of the scanner that lock directly into the pole. Once it's clicked in, it is rock solid. This allows you to apply consistent pressure against the concrete surface, which is vital for the sensors to get an accurate read. When you're using the pole, your center of gravity changes. I always recommend practicing a dry run scan without recording first. This ensures you can maintain a straight line over the entire length of the scan area. If you veer off course, your rebar spacing data will be skewed. With the pole, you can reach those difficult slope surfaces or overhead areas without the need for expensive scaffolding or risky ladder work. Alright, let's get to the main event, the scan itself. There are different modes on the PS300, but for professional documentation, we use quick scan and record. First, we select our direction. I'm starting from the top and moving down. I press the red button, the green light comes on, and you'll see that red recording dot on the screen. While you are in recording mode, the screen does not show you the live cover depth. Why? Because the processor is dedicated to capturing high-fidelity raw data from all 5 sensors. It's prioritizing the truth of what's inside the concrete over a quick preview. Now I'm going to do something important. I'm changing the direction on the screen to bottom up and scanning the same path again. In the next video, when we get into the Profire software, I'm going to show you how these two scans compare. Scanning in both directions is a great way to verify your data. If the results are identical, you know your calibration was perfect. If the device beeps and tells you to calibrate, do not skip it. Calibration adjusts the sensors to the ambient electromagnetic environment of that specific site. Concrete is full of minerals and moisture. The scanner needs to zero out to give you that sub-millimeter accuracy. The scan is finished. Now let's see what we actually found. Even without a computer, the PS300 gives us incredible insights. Look at the clarity here. This is a nice, clean scan. I'm seeing my rebar laid out perfectly perpendicular. I can see the cover depths. 55 millimeters, 55 millimeters, then a slight dip to 49 millimeters. If you look closely, you'll see how the 5 sensors work. This device doesn't just have one eye, it has 5. This allows the scanner to see the rebar even if you aren't perfectly centered over it. If I double tap a specific bar, I can see the highlighted data. I can see exactly how far into the scan that bar is located. We can also pull up the statistics screen. This is huge for on-site inspections. It gives you the median cover, the mean, and the standard deviation. If the engineer's spec says you need a minimum of 50 millimeters cover, and your median is 48 millimeters, you know right then and there that there's a potential compliance issue. You can even change the parameters after the scan. If you realize the rebar diameter was actually 16 millimeters instead of 12 millimeters, you can adjust that setting on the screen, and the device will recalculate the cover depth based on the new diameter. That's the power of recording raw data. Now, I want to show you what happens when things don't go perfectly. I'm going to do a third scan, but this time I'm intentionally going to scan at an angle, not perpendicular to the rebar. Look at the screen now. See how the rebar looks fuzzy or elongated? That's because the sensors are crossing the rebar at an angle. This is why technique matters. If your data looks like this, save it anyway, but make a note. The Profias software can sometimes help correct this, but your best bet is always to aim for that 90-degree intersection. Also notice the difference between raw data and dimensioning views. Raw data looks like a traditional radargram. It's what the sensors actually see. Dimensioning view uses Hilty's algorithm to turn those signals into clear, easy-to-read bars. For most fieldwork, stay in dimensioning view, but keep raw data in your back pocket for troubleshooting complex rebar cages. That wraps up our deep dive into the Hilty PS300 Ferris field workflow. We've gone from setting up a professional project to using the telescopic pole for high-reach areas, and finally analyzing our data right there on the touchscreen. This tool is an investment in safety and accuracy. It takes the guesswork out of concrete work and gives you the professional edge you need. But we aren't done yet. In the next video, we are taking the C1 column and slab 1 data and importing it into the Profias software. I'm going to show you how to create 3D visualizations that will blow your clients away and how to generate automated reports that meet industry standards. If you want to keep up with the latest in construction technology and high-precision testing, you're in the right place. Subscribe and like this video to help the channel grow, and so you don't miss the Profias Masterclass coming up next.